Geert, again, I had a question of a customer and they talked about moving to the cloud. They wanted to become cloud native. And of course, they wanted to do Kubernetes. Mm-hmm. And well, this is not the first time that I got this question. And I have the idea that Kubernetes is more or less the hammer that is used to solve any kind of problem. But not everyone actually understands what kind of problem we are actually solving with Kubernetes.
Yeah, I can relate to this. Last week I was at KubeCon and Cloud Native Con, a large conference where like over 15,000 people, and they all want to do cloud native stuff. And what I noticed during the keynote, the person presenting asked the audience, like, who is here for the first time doing Kubernetes and cloud native stuff? And almost half of the audience raised their hands. So for me, that was a notion of, okay, this community is still growing a lot, and people are still learning about this stuff. I was expecting it more to be a gathering of a lot of experts on the field, but no, it's really, both experts and also a large group of people who want to do cloud native stuff, but don't know how to do it. I think we can have a nice episode on our podcast on explaining what cloud native is, what are the problems that you can run into, what problems does it solve.
Yeah, and maybe also talk a little bit about what Kubernetes is and what it tends to do. And maybe we should invite a guest. But let's first start the podcast.
Yes,
Welcome
let's go.
to the Lead Podcast.
The Lead Podcast, a podcast for leaders in engineering, architecture, and development.
So for this episode, I invited Chris van Sluijsveld, to have a discussion on this topic. He knows a lot about cloud native and Kubernetes. Maybe Chris, you can introduce yourself.
Yeah, thanks Rene and Geert for having me on this podcast. So I'm a cloud native consultant at Xebia, helping customers to help them on their cloud native journey. And we both visited KubeCon last week and had a lot of interesting insights. So let's take a look at that.
Yeah. So what I wanted to start with, Rene also said it, for Kubernetes and cloud native. For a lot of people, this is new, but it's not a new thing, right? Kubernetes exists for over 10 years now. So maybe we can take a few steps back and why are we all doing this and why did this movement start in this way?
Yeah, and maybe even one step further back, Chris, maybe you can explain a little bit about cloud native in the first place. What is it? And what is it all about when we are saying we want to become cloud native?
Yeah, so maybe the definition of cloud native, right? So there's different definitions, but if you would take the Cloud Native Compute Foundation definition, then it's about ambiguous systems, loosely coupled, running on the cloud or on-premise or things like that. Where people try to abstract certain things away that are done multiple times, so they can easily do that again. Mm-hmm. Of course, it all started with having one idea of how do I package my application. So that introduced the concept of containers, right? So people started to do containers at first.
Because we had these old applications running in a data center,
on
premises, and then we needed to move it to the cloud, and then there were multiple options. We have IaaS, we just run it on a virtual machine, which is basically building the data center again and again. And then this whole concept of containers, allowing to package your application in a sort of...
with all the dependencies, right? First, maybe it was executables or zip files, and containers gave you the notion of, okay, these are my applications, these are the dependencies, their platform, run it for me.
Regardless of the compute power underneath the platform. So all of a sudden, it didn't really matter if you were running on your local PC, in the data center, in the cloud. It was all running because it was all packaged in this nice container format.
True. So of course, one container is non-container. So if you would have, of course, your application landscape suddenly became maybe consists of multiple applications.
Also consistent with the whole microservice
movement
that came, right? So that happened around the same time, maybe, so that
definitely that accelerated, of course, the adoption of containers. And of course, you needed something to run those containers on. Now, the big container orchestration war started. Multiple vendors offering a platform to do container orchestration. Maybe think of DCOS or Docker Swarm, Service Fabric from Microsoft as well. And of course, Kubernetes was also one of those platforms coming up 10 years ago.
Back then was mainly a Google.
It started at Google. But now I think we can say fast forwarding to today, 10 years fast forward. It has become the standard way of running your containerized workloads.
I think what also changed a lot when we talk to customers, it's not only where we first had, the question, where are you going to host your application? Are you going to run it in the virtual machine? Are you going to run it on a web app? Or which cloud are you going to host? Running it in a container, running it on a cluster, on a container orchestrator is more or less, it's almost standard. It's not a question that is going to be asked. It's like, that's exactly the question that we started the episode with. Companies say, well, we want to run in the cloud on Kubernetes, not knowing exactly what that actually means.
Yeah, but that seems to be the initial question. We want to run it on Kubernetes, and of course this starts with containers, right? So containers are the base thing that we need to implement to run our applications anywhere. But from there's still a lot of options to either do this on Kubernetes, which is a platform that is implemented by all the different cloud providers, right? You can do this on, you could even run this yourself on VMs on premises or in the cloud IaaS if you really want this. But of course, all the cloud providers also invested in these managed solutions for Kubernetes, like AKS on Azure or EKS on AWS or GKE on Google. So the nice thing about that is that they all run Kubernetes, and it looks like it basically is the same product that we run there. So if you would run your application on AKS or EKS, that would look exactly the same. The interfacing, the API of that Kubernetes is exactly the same.
Yeah.
But it's still the notion but you still have to first have your application or your applications or services packaged in a way that they can run on that platform, right? So that's where still the containerization comes in. That's first step to do as an organization. Make sure that your applications are packaged in that way. So all the dependencies are boxed in that container. And then you can think about, where I'm then going to run that container.
So that was exactly the question that I wanted to ask. Because for me, sometimes it feels a little bit of a overload. People, they have for example, the Christmas card application that they run once a year to send 20 Christmas cards to their customers, matter of speaking. And then they say, we need Kubernetes and this whole thing. But maybe that is not a good option. So maybe we can also dive a little bit into what options are there. Geert already explained it a bit, but how do you make a decision on either use a platform like Kubernetes or maybe not use a platform like Kubernetes? So what are your considerations there, Chris?
Yeah, so I think it really depends on the scale of your platform, right? Do you want to do you have one or two containerized applications that you want to run, which then maybe would benefit from just using a SaaS service or a platform service where you just run go run this container and give me an URL which I can call? Or do you say, I have a large landscape of applications, but I also want to host maybe other services in that platform as well, which are not built by ourselves, but just maybe open source products that are in the market for let's say, for example, Airflow or other component that you want to run.
Yeah. So what I see is that a lot of the cloud vendors are also investing in making running these containers easier without needing the whole Kubernetes, right? So Kubernetes is still a very complex beast. It was that 10 years ago, and it probably is even more complex today, because it also has more capabilities. So it really also depends on the organizations. We also see the whole DevOps movement that we want to make teams responsible from beginning to end. So it should also be possible to just run your own container somewhere in a very easy way without Kubernetes. And that's what you see a lot of the cloud vendors do, is also making it possible to run these containers in an extra abstraction over Kubernetes. For example, on Azure, this is called Azure Container Apps. On Google, they have Google Cloud Run. So a lot of these.
Yeah, so it's basically the SaaS for containers. You just build your application.
Yeah.
You package that in this case a container, and then you say to the cloud platform in this case, well, I have this container here.
Yeah.
Please host it for me. Then you get an URL back, and you get some basic.
But what you actually do see is that those like platform abstractions underneath the hood still run on Kubernetes, so they're still mostly compatible with the Kubernetes API. So the cloud vendors are adding another abstraction, but the compatibility is still there. So
if you want to decide later.
So maybe you start small and start as a company. You start with the small services. You only have a couple. Investigate. Okay, we can run it on maybe Azure Container Apps. Your company grows or more requirements come in. Maybe then it's time to switch to a proper version of Kubernetes.
Yeah, you don't have to rebuild everything. You just pick up the same code base.
Yeah, you just pick up your containers, move them to the other platform, and you can run again.
That's the real benefit of containers. Also comparing that to, for example, serverless technology, which is also often called cloud native, because it's also born in the cloud. And often it has a lot of the aspects that you really want from the cloud, only paying for what you need, etc. But you really tie into the development model of
the specific cloud.
Of that specific cloud. So Lambda functions have a completely different programming model than Azure functions, for example. So if you would, you can both write them in the same languages often, but that does not mean that the code looks anywhere similar. Of course, your business logic somewhere in that application looks the same, but there's a whole lot of stuff happening around that is really specific, and that's the thing that Kubernetes has. They have different implementations on the different cloud providers, but the whole interface around it is the same. They have the same API and the same capabilities.
Yeah, but I think it's a very important point, because I think in the definition of cloud native, like in the past, a lot of discussions always went to, okay, if you can do IaaS and you run a virtual machine, well, then you are still like cloud agnostic, because it doesn't really matter where you host the virtual machine. Or you do PaaS and you use web apps or functions or lambdas or whatever cloud native. They also call it cloud native PaaS functionality. Yeah. And then you were really cloud native. But now it also shifted a little bit to, you can also choose something like Kubernetes and still be cloud native. Yeah. And so the definition of what is cloud native or PaaS versus something else shifted also a little bit towards something else.
Yeah, and the word cloud native is a bit weird, because if you look at the Kubernetes ecosystem, you could also run this on premises with things like OpenShift, for example. There's also managed solutions for your on-premises situation, which makes a lot of migrations from on-premise to cloud or do hybrid things also possible, because it's all running on the same kind of infrastructure.
Yeah. Yeah, so going back to what Geert previously said, so if you have cloud native, but maybe also you can think of other services also as Azure native, right? So maybe Azure Functions, as an example that you just mentioned, is maybe not more Azure native, or if you talk about Lambdas, AWS native. It still has a lot of benefits. You get all the elasticity and the scaling of the cloud, but you really tie into that programming model for that cloud. And maybe where cloud native then shines is it really abstracts all the really cloud vendor specific things away, and it becomes maybe cloud agnostic even.
Yeah. So summarizing a little bit, there are multiple options when hosting your application within a container. You can do it yourself by doing it on your VM. You can choose a managed service in a cloud, or you can host it on smaller services and just provide them with the application in a container, and then the cloud platform takes care of the rest. So when diving a little bit deeper into the managed service, like, okay, we are going to choose a bigger scale. We want to be cloud agnostic. We have a large scale application, so we are choosing to host it within Kubernetes. While delving a little bit more into Kubernetes, because that is the solution that is provided to us from our customers. We want to do it in Kubernetes, but what actually is Kubernetes? What was it? And maybe also what is it nowadays? What was it in the past? And where is it heading?
Yeah, so maybe looking back, so it started, of course, as one of the orchestrators back then, when compared to DCOS or Docker Swarm. But it's become way more than that, right? There's a really big, what they call an extension model in Kubernetes, where you can add your own APIs, which all implement the same are all in the same platform. So then it not only just runs containers, but you can actually run everything, right? So what you see is that there's a push for batch jobs running in Kubernetes, but also maybe machine learning or AI workloads. But also WebAssembly as a big trend for the coming years, where maybe the containers are not the format for the future anymore, but it's more about even smaller abstractions, which you can run anywhere.
Yeah, and I think that the nice thing there is that it started off with orchestrating your own containers.
Yeah.
Basically, the application that you have in control, your application. And if you look at your whole tech landscape, that consists of some custom built applications, but there's also things like a data platform or a messaging platform or all kinds of AI now, of course, AI machine learning. So all those kind of platforms are often built up out of existing components that need to work with each other. And the nice thing is all these platforms also moved to containers. So you could also run those on such platforms as Kubernetes.
Yeah. So it actually becomes more or less your operating system in the cloud, where you just install an application on your OS, in this case Kubernetes, which hosts your data platform, or which can host your AI platform or a part of it.
So looking at the OS for the cloud, like Kubernetes, existing for 10 years, is part of what they call the Cloud Native Compute Foundation. So there's a whole organization behind it. It's orchestrated by the Linux Foundation. Of course, in the beginning, only Kubernetes was part of the CNCF landscape, but now there's a big list of 250 out-of-the-box open source solutions governed by the CNCF Foundation, which you can install on Kubernetes, which provide, for example, maybe an identity platform out of the box, all running on a Kubernetes cluster. So if your application landscape needs something for identity or maybe for messaging, there's all kind of products already existing which can already run on that platform. And because it's OS for the cloud, it can run on multiple cloud vendors. You can also easily shift between those two and not choosing a different tool for each cloud provider.
Yeah, I liked how the CTO of the CNCF said, like, Kubernetes, it's not a platform to run your apps, but it's a platform to run other platforms. And one of those platforms could be your application platform.
Yeah.
But as I said, there's multiple platforms, your data platform, etc. You could all run those in a cloud native way. And then all of these platforms get the benefits of the possibilities of moving between on-premises and cloud or different cloud providers.
No, and I think that is really, really powerful. I was working at a big enterprises before, and what you see happening a lot is that when they initially chose a cloud provider strategically, for example, they chose Microsoft as their strategic cloud provider and moved a lot of things to Azure. Then AWS came in or Google and said, well, we have a better contract for you. And that is not about $100 or $200. It is like multi-million dollar contracts. And if you can save multi-million dollars, it's also worth the effort to do something. And I think choosing something like the OS for the cloud, where it doesn't really matter what the underlying cloud or infrastructure is, but you can just move your whole infrastructure along, is really powerful to also spread it. In case of risk spreading, I don't want to put all my eggs in the same Microsoft or AWS basket, but also in terms of cost. I think it's really, really powerful to not host it Azure native or AWS native, but just have this abstraction layer in between.
Yeah, and of course, there's always benefits to do it in a Azure or AWS native way, but then for really specific things. And I think the more the time grows, the more of these platforms are actually capable of running on the Kubernetes, which makes a choice easier to go here. But one thing, because now it feels like Kubernetes is the next
the golden bullet.
Yeah, the next
bullet.
best thing after sliced bread. What Kubernetes still has, and even if you have a managed solution, so let's say you're running on AKS or EKS or GKE, yes, this is a managed Kubernetes, but still Kubernetes is a very large beast which you need to tame. It needs to be managed by yourself. So this adds a lot of complexity, and also how does this fit with the DevOps movement that we also see? So we want to make it possible for the DevOps team to build and run their own applications, including infrastructure. How does that work with such a complex environment?
Yeah, I totally agree, Geert. So Kubernetes, of course, is a nice platform, but it's so extensible with all those APIs and all the things that you can add that it's really, you always need a team of its own to manage it and to keep a track of it.
At least one team.
At least one team, so that can manage that platform. So maybe your development teams can actually focus on the applications that they're building, and you have one central team maybe taking care of the platform. So then you get see the notion of platform engineering, of a platform experience becoming more important in those kind of organizations.
And is that platform team then more focusing on running? We had a comparison in the previous episode before, you have water and electricity. They need to make sure that all the plumbing, all the water, all the electricity is running.
Yeah.
That is the platform. So you can host an application on this platform.
Yeah, as a developer, I would rather say, okay, the only thing I have to worry about is that my application is packaged as a container, and then make sure the platform teams make sure that there's an interface for me to run that container. And if it's underneath the hood, if it's AKS of Kubernetes on Azure, of Kubernetes on-prem, I don't really care.
Yeah.
As a development team, I only care about packaging my application and run it.
Yeah, so you need to specify a number of interfaces that you want for your container to interact with, like ingress or those kind of things. And from there on,
the platform should take care of the rest.
And how does that fit into the DevOps model? So where are you still responsible for as a DevOps team?
No, I think of course, so that platform not only has to run that application, but also has to provide the interface for those development teams to interact with that platform, where they can see, for example, logs and errors and traces, etc. But also can troubleshoot things when things go wrong, because you don't want to end up in a situation then when the application doesn't start, you have to open a ticket again to a central team saying. Please help, it isn't working.
So it's still DevOps, but in the scope of the application. So they build and run their application on a platform, but they are not managing the platform itself. Like installing it, like 20 years ago, you installed your application on Windows. As a platform, as a team, you were not responsible to make sure that Windows was up to date and secure. That was not your problem.
No, and of course DevOps is if you want to do pure DevOps, or if you say you really need to be responsible for everything, then you also need to be responsible for the electricity of your data center. That's so where do you draw the line? I think with the current platform engineering, you put a really nice boundary where you say, well, everything application specific, that belongs to the DevOps team. And all the plumbing, so networking, those kind of things, that belongs to someone else.
Really treating the platform that maybe is Kubernetes as like a platform on its own,
but also a product,
or maybe as a product even. Where you say this is a product that we as a platform team deliver to our development teams, right? And that's also it has to be up to par to accelerate those teams.
So. Having heard all these things, we started with the question, companies want to become more cloud native and they are asking for the solution. Kubernetes, and sometimes it is the solution, but also with some things you have to consider. But what the question on, we want to move, and I think we think that cloud is the way to go. What would you recommend to these companies that want to start with their cloud native journey? How to begin when considering all these things?
Now, maybe a good practice is to first start with looking at, for example, the cloud native maturity model that the CNCF provides, where you can actually think about all the different aspects about cloud native technology, but also people and processes. So what do I need to think of change there, right? Because we are as engineers, maybe more focused on the technology, and then it's Kubernetes, but there's other things as well, like the governance and the processes and people that we need to have to support that platform. But the other one would maybe also be decide on the hosting model. Do we really need Kubernetes, or can we just start out with maybe one or two containers in a simple container app service, for example, and then grow from there? And of course, the operating model is also important. Okay, how are we going to run? Are we going to do full DevOps, where every team runs their own container orchestrator, or are we going to in a route where there's a platform team which provides a product to the other teams to run that?
I think that ties into what you said in the first step. It's about people and process as well. So are your people skilled? Do they understand? Do they know how to handle it? Are they even aware of what is possible, et cetera, et cetera? And the processes around it, like are you going to have a ticket system where a central team is going to do everything? Or are you going to enable self-service and all that stuff around it so that teams can autonomously build on the platform? Makes sense.
And there's it's quite a journey, right? So installing Kubernetes itself is fairly easy to do that out of the box. But there's so many more components that you also need. So it's quite a learning journey. So I would advise keeping it simple at the start. And go for such an abstraction if that's fine. If you're working at a startup, for example, those things could be enough for you. And of course, in enterprise, you have more time and materials to run such a platform team that can really set everything up, including all the tools that you need to run a really big Kubernetes platform. And then you can look at the whole CNCF landscape which has, as you said, 200 plus projects and tools that you can use to set up your environment. Yeah, that's then a journey that you need to investigate which products do fit you well or not.
Yeah.
And of course, the CNCF helps you there as well. They have this notion of different projects, an incubating project, which is fairly started, into graduated projects, which have proven themselves also in enterprise use.
Yeah.
So it makes the choice a bit easier. Of course, there's also competing graduated projects, which, you need to figure out which fits you best. So it's not an easy step.
No, I think that we covered quite some topics, and again, a lot of things to consider when having the statement we are going to do cloud native. It is not as simple. There are a lot of choices to make. So thank you, Chris, for
no problem.
Enlightening us on a number of these topics. I think that the episode is already over, and we spent another half an hour on these things, and we can I think spend much more half hours on this same topic.
Yeah. Well, let's wrap it up. Thanks for listening, everyone, and hopefully you'll listen again in 2 weeks for the new episode.
Yeah. Thanks, Chris.
Thank you.
Bye bye.
Thank you. Bye bye.
The Need Podcast, a podcast for leaders in engineering, architecture, and development.